lot of considerations when you're talking about building a wind farm, and it's not just as sticking a pole in the ground and watching the wind turbine turn.
The faster the wind is blowing, the more electricity that will be produced. Another factor would be how often that wind is blowing.
When we look at the wind turbines, they're constantly changing position. The computers on board are sensing wind direction.
Another factor would be the turbine size.
They're very large blades. They're 130 feet long.
We have to look at land area because it's not really worth it to us to only put up a couple of turbines.
Our job site is about a 15-mile to 30-mile span.
These are 120 wind turbines that are already up and running.
A wind turbine, you can think of it as the opposite of a fan. A fan has electricity running to the fan, and it moves the blades to produce wind, like a breeze for you. Well, a wind turbine is the opposite. It uses the wind blowing at the wind turbine to move the blades, which then generates the electricity. My name is Emily Hardy. We are in downtown Houston at the Horizon Wind Energy headquarters, and I am a wind analyst. We look for good areas in the United States to build a wind farm. In order to find a good wind site, it takes several years. We have meteorological towers up measuring these winds, looking at the patterns, how fast the wind's blowing in the winter, how fast the wind's blowing in the summer, in the day and at night. We'll collect all the data, and we can estimate what the winds would be for the different areas of the wind farm and how much electricity we could produce. And then once we've decided to build a project, it will be handed off to other departments, and then they will start construction.
My name is Johnny Goff. I'm a project engineer for Horizon Wind Energy. I'm in the construction department. But when you're talking about building a wind turbine, a lot of big pieces and big machinery involved. You want to make sure that the roads are strong enough to hold all this big equipment. I want to make sure that the soil is strong enough to hold these big wind turbines. I mean, you're talking about 400 feet in the air. You want to make sure that it stands up correctly. Each foundation has about a 52 feet diameter and 9 feet deep. That's a lot of concrete, especially when you're talking about 120 different foundations. We have a lot of managers to manage different areas.
I'm Scott Alexander. Right now we're at the Maple Ridge Wind Farm in upstate New York, just outside the little hamlet of Lowville. We're standing at the site of a tower that will be put in the air here very shortly. One wind turbine consists of many different parts. We have the concrete base, and that's what everything rests on. Then we have our tower, which consists of 4 pieces. We have a base, a lower mid, upper mid, and a top.
This is the nacelle, which has the generator.
This is the heart of the wind turbine itself. This is our nacelle. This contains our generator. That's what we use to produce power.
A 1.5 megawatt wind turbine could probably produce enough electricity for about 750 homes.
We've come a long way in the wind industry. A lot of different things have improved using technology. When we look at the wind turbines, they're constantly changing position. We have several computers on board in each unit. The computers are sensing wind direction. So for 1 hour, they all could be facing the northeast. The next hour could be facing the northwest. They're not only monitoring the wind speed, the wind direction, they're looking at oil temperatures, they're looking at the pitch of the blades, and they're calculating, they're using all that information all the time to optimize the efficiency.
Engineering is basically problem solving. You have your questions and you see what's the best route to solve that problem.
We use a lot of different equations.
I'm using algebra, I'm using geometry, I'm using trigonometry.
Y equals mx plus b.
We talk about air densities, air speeds.
And that's cubed, velocity to the 3rd power.
Sometimes you have to go out and get a pad of paper out, set it on the truck, and start scratching out formulas to actually calculate what's going on out there.
The market for wind energy is booming right now, and so there's jobs just opening up left and right. I've always liked math and physics, so those were great classes to take to get you ready for a job like this.
I enjoy coming to work every day, knowing that I'm doing something to help people, knowing that I'm doing something to help our community and our environment, and I love building things. I like to see the beginning, I like to see the end of it, and know that I had something to do with that, to see that end product.
There's always going to be wind. It's always going to be available. There's no CO2 emission, and so it's a clean energy.
We really don't take up a lot of area space on a particular farm itself. The farmer can go on, he can raise his cows, he can grow hay, he can grow soybean, he can grow corn, yet off on the back corner of his property we're also producing energy. So we're kind of a partner with this farmer. He's going to receive a revenue stream just as he would for his crops. He's kind of farming the wind himself, using some of his natural resources to produce energy.